Today we're talking about slopes of lines graphed in the coordinate plane. Now, before we jump in with a few examples, it's important for us to understand what the slope is. Slope really just measures the steepness of a line. And we say that the slope is represented by this variable m, and it is the rate of vertical change over the rate of horizontal change. So between 2 points on a line, we can measure the slope by taking its rate of vertical change, that's the one that goes up and down, and dividing it by the rate of its horizontal change. That's the one that goes left and right. So we use this sweet little formula here. Whenever we have 2 points on a line, we call them x1, y1, and x2, y2. We say we can find the slope of that line by subtracting my y coordinates and dividing it by the difference in my x coordinates. Now, we also learn this nifty little way to remember that it's rise over run. I always want to subtract my y's on top and my x's in the denominator. All right, now, as we're going to find out here in just a second, parallel lines, they have the same slope. That's why they'll never intersect. Whereas perpendicular slopes have opposite reciprocals. Now, you'll learn what that means as we go. All right, before we jump in here to our example, let's just take a look at this sketch again. So remember, here's our 3 lines. We have line A, B in yellow and C, D in blue. To find their slope, you can simply count between the 2 points that are on this graph. The amount of vertical change here is 1, 2, and then horizontal change is 1, 2, 3. So the slope there is rise of 2 and a run of 3, or 2/3. Now let's move CD so it also has a rise of 2 and a run of 3. And as soon as I do that, you see that these 2 lines, AB and CD, are now parallel to each other. They have the same slope, rise 1, 2, and run 1, 2, 3. Now, if I change that, you can see that they are no longer parallel to each other. In fact, they now intersect. The slope of CD now is rise -1 and run 1, 2, 3 to the right. So now my slope of that CD is negative. Any slopes that are negative will always slope down and to the right, and any slopes that are positive will slope up and to the right. When you have a horizontal line, which runs parallel to the x-axis, your slope is 0. And when you have a vertical line, that's one that goes straight up and down, you're going to have what's known as an undefined slope. All right, let's go back to some of our examples for today. In example 1, we want to find the slope between these 2 points, -3, 7, which we'll call x1, y1, and 5, 3, which we'll call x2, y2. So remember, we're going to take the difference in our y's, so we'll say 3 minus our 7, and we're going to divide that by the difference in our x's, 5 minus a -3. Now that becomes a -4 in the numerator, and that's 5 minus a negative is plus a positive, so that becomes 8 in our denominator. Now we should always reduce this to our lowest fraction, which is -1/2. So we say the slope of this line, there's my little cursive m. Let's try that over again. We're going to try that. A little bit better. There's my cursive m. The slope then of this line is -1/2. All right, let's take a look at example 2. Example 2, we have these line segments that are graphed over here in the coordinate plane, and we simply want to find the rise and the run of these different segments. So in part A, it says to find the rise. Now remember, rise is your vertical change for segment AB. So to go from point A to point B, I'm going to come up from 2 to 4 to 6. So my rise here of AB is 4. Now let's find the run. That's the horizontal change, so I'm going left to right of this segment AB. So here I am at A, and it's at 0. If I jump over to B, it looks like I jumped over to 1, so my run is 1. All right, next we're going to find the slope of AB. Well, slope of AB is simply the change in y over the change in x, which is equal to 4 over 1. So this slope is equal to 4. All right, next let's find the slope of EF. Here's EF. It looks like I'm going to rise by coming down 2. So that's a -2 for my rise. And my run is going to go to the right 1, 2, 3. It looks like it ran 3. So my slope of EF is negative 2/3. Next is the slope of CD. Well, here is CD. It is a vertical line. So those vertical lines are known as undefined slopes. Find the slope of GH. GH is a horizontal line, goes straight across, and we said that our slope here is 0. All right, here we go in example 4. We are asked to find the slope between these two lines and determine if they are parallel or perpendicular, or neither. All right, well, when we have them graphed on the coordinate plane, we can just use this idea of rise over run. We can actually count between our coordinates. So let's find the slope of UV first, simply by counting its rise and its run. I'm going to rise 1, 2, 3, and then I'm going to run 1 to the right. So the slope is 3 over 1 for UV. Now let's try to find the slope of YX. So we're going to we're going to do our rise first, which it looks like it comes down 1, and then it's going to run 1, 2, 3. So UX, or YX here I should say, has a slope of negative 1 down and 3 over to the right. So you can see here that these are opposite reciprocals. So these two lines are going to be perpendicular to each other. All right, let's try the next one here. And you can tell right away that they're not parallel, but let's find the slope of GH. So we're going to count 1, 2, 3, 4. So it rose 4, it rises 4, and then 1, 2, 3, 4 again for its run. So the slope of GH is 4 over 4, which simplifies to 1. And now let's find the slope of IJ. So if I erase these two lines here, clear that up a little bit, our rise is down 1, 2, 3, 4, 5, 6, 7, 8. Now we're going to run 1, 2, 3, 4. So it looks like our line IJ is going to have a slope of negative 8/4, which simplifies to negative 2. Now 1 is not equal to negative 2, nor are they opposite reciprocals. So for these two, we just have to call them neither. Okay guys, your turn. Give the graph here, example C, a shot on your own. We'll talk about it tomorrow in class. All right, in the next one it says to find the slope of each of these segments and tell if the segments are parallel, perpendicular, or neither. So here's our example of AB. We're going to find the slope of AB by taking the difference in our y's. We'll say negative 3 minus 2 and divide that by negative 2 minus 0. That gives us negative 5 over negative 2. Now we have a negative divided by a negative, and we know that that's going to simplify to a positive 5/2. All right, in CD, now we're going to take the difference of our y's here. So we'll say our slope for CD is equal to 0 minus 2 divided by 3 minus a negative 4. So this will simplify to negative 2, and this becomes plus a positive. That's negative 2 over positive 7. So that gives us a slope of negative 2/7. Now, 5/2 is not equal to negative 2/7. And therefore, they are not parallel to each other. What about perpendicular? Now, we mentioned earlier perpendicular slopes are opposite reciprocals. So the opposite reciprocal of 5/2 means that you have to switch the top and the bottom. So the bottom is now your numerator, the top is now your denominator. So this becomes 2/5. And opposite means that they change values. So 5/2 was positive, which means negative would be the value of this new fraction. So this is an example of opposite reciprocals.